In this lab, you are going to observe waves properties using a ripple tank. Let me explain the parts of a ripple tank. This is a transparent tray that holds water supported by 4 rods to keep a height from a flat surface, in this case, a lab table. This is a overhead light that projects the water ripples on a white piece of paper placed under the tray. Ripples on the surface of this tank are created by this electric motor attached to a vibrating bar suspended by the springs. This bar has holes for attachments like a dipper and this straight wave generator. The motor and light are connected to the power supply in order to operate. When the power supply is on, the metal bar vibrates, creating ripples on the surface of the water. With the light shining on the water ripples, bright lines will be observed on the white paper under the tank. Now that you are familiar with the operation of this ripple tank, I'm going to show how to connect all the pieces. All 4 legs have this screw that needs to be attached right here. To save some time, so all 4 they are already connected. It's very light. Now we have all these 3 poles inserted in these holes. This is the halogen lamp unit. The electrical specification of this lamp is 12 volts, 20 watts. And this is a closer look of the halogen lamp. So I'm using this boss to connect the light on the pole. This is the spring support. This is the metal bar with the motor, and these are the holes for the attachments. The motor and the lamp need to be connected to this power supply. So in this power supply, we have 3 sections. One for the ripple motor, one for the stroboscope motor that I'm going to explain later, and this section is for the lamp. Because the electrical specification for this lamp is 12 volts, 20 watts, we need to match this with the power supply option. So here I have the top one, 12 volts, 20 watts, and the bottom one, 6 volts and 10 watts. So the top one here will be our option. We need these 2 cables to connect the lamp with the power supply. Now notice these terminals are not color-coded because can be either AC or DC. So you can connect either way, this way or this way, or vice versa. Now this is the wire that comes from the motor. Also need to be connected to the power supply. So we are going to connect to this section right here, positive with positive and negative with negative. This is a manual stroboscope. Place your finger here and rotate. This power supply has a section for a electrical stroboscope. We don't have this one, so we don't need to connect. Now, it's important to notice that after you connect this power supply to the power and power on, the only knob that you are going to turn will be this one, which is the knob to change the vibration of the ripple motor. This knob is not gonna be used because it's not connected to anything. So this is the power cable for the power supply. So this needs to be connected here. And the other end to the outlet. It's important that you remove all those cables from the water going behind all these. For example, get all this cable from the light. I'm going to run a test to make sure that all the electrical components are working, everything is connected correctly before placing water on the tray. Light is working. Now let me check the motor. To test the motor, I'm going to change the knob, and it's working. Now I'm going to attach these two dippers, and I'm going to attach this straight wave generator. I had to do a couple of modifications here in order to keep this bar a little bit more straight. I moved the light all the way to the back, and also I turn this clamp backwards, as you see, and now I have the bar kind more straight at the beginning of the tank. I didn't want the bar here right in the middle and miss all the waves from the back. I want to produce as much as I can waves starting right here. Please make sure when you adjust this clamp, because it's plastic and feels like cheap plastic, don't tie too hard because you might break. So adjust slowly until you get like a stable situation. Another problem is that this pin for the straight wave generator does not fit here. If it does, kind of hang a little bit. So this hole works better, but it's kind of too wide and not very stable. So I got a piece of tape and wrapped around this, and now it's kind of fit a little bit better. And yes, let's see how it works now. Now I'm going to pour water, and when you do, if you are going to do this, please do it slowly. You don't have to fill the whole tray. I will say leave this amount here. There is an amount, like, don't have to go all the way to the edge of the tray. Now the flat or straight wave generator is in contact with the water. So now I'm going to turn the dial of the motor up slowly to create waves. Now we can see waves being projected on the white paper. You can take a picture, enlarge the picture, and see where the bright lines hit the marks on the ruler, and that way you can measure the length of one wave. Now remember that the distance between two bright lines is one wavelength. Now I'm going to remove this straight wave generator and work with those dipper. One note here, when you are working with this bar, like disconnect attachments or adjust the level of this bar, make sure that you disconnect the motor, and you can do this by turning the knob down to 0. Now I'm going to drop one deeper and make sure that it's touching the water. So this is the projection of the water waves using one dipper. So now in this step I have both dippers down, and this is the projection on the white paper. So we notice here there is a interference between both circular waves. To observe the pattern a little bit better, I'm using the stroboscope, and let's see what happens. So we definitely can see way better with this device.